Well, it's a great pleasure to be here. Thanks for joining us this evening. I'm going to talk about Kotlin. Just to kind of start with a little story. I program in 15 different languages, and I just love all of them. With 15 different languages, you obviously ask the question, people often ask me, what's your favorite? Well, the reason I say that I'm good at 15, I use 15 different languages is that I'm not good in any one of them. But I just love languages. And so when Kotlin was coming out, I had the opportunity to meet Andrew Bereslav, the guy who wrote Kotlin, or at least one of the major contributors to it. And I asked him, hey, Andrew, there's Groovy, there is Scala, there is so many other languages, and you've taken all these wonderful features from all these languages, and you've created this one beautiful language, but why should I care? What is it that Kotlin does that other languages don't? And I think he gave me the best answer I could ever expect. He kind of shrugged and said, well, this is not the language for you. And I took it and said, great, I will not then focus on it. I kind of ignored it for a while. And then a few years went by, and I would keep hearing Kotlin and Kotlin, Kotlin. And one thing that was really weird about Kotlin is programmers never came to me and said they like Kotlin. They always said they love Kotlin. And that kind of intrigued me. Why would somebody love a language than just like it? And so I started really playing with Kotlin to look at it. And then, of course, as you know, a few years ago, Google made a very important announcement that Kotlin would be a first-class language for Android development. And overnight, the adoption really shoot up. And of course, a couple of months ago, as you know, they said it will be the first language for development of Android applications. Well, then, of course, Spring Team also started adopting Kotlin. And you can start seeing Kotlin in so many different places. And as I got really excited about Kotlin and started playing with it, I saw companies actually being intrigued by it, interested in it. So I said maybe I should pay a little bit more attention, get a little bit more serious about it. And I do have to admit to you that I was absolutely naive, because I said to myself, oh, I've written books on languages. What is the big deal? I can write about Kotlin. Biggest mistake. Because people tell you Kotlin is a much better language than Java, it's a fluent Java and all that. I would say all that is a lie, because Kotlin is a lot more than being just a fluent Java. And I started writing about Kotlin, and the little I know how much there is to write, and it ended up being the biggest book I've ever written. In fact, I'm so happy to tell you that as of today, I just finished the book. So it is actually going to typesetting. Thank you. It's going to typesetting as of a couple of days from now. So I'm so happy to get done with this. But it's been a really interesting journey. And one of the reasons I often write a book is, people often say, you write a book because you know stuff. Well, actually, honestly, I write books because I want to know stuff. And of course, that's been a really good experience learning this beautiful language. And that's what I want to talk about today here, talk about what's Kotlin. Well, Kotlin is one of those really few languages that is truly a multi-platform language. You can write code in Kotlin, you can compile it down to Java bytecode, you can compile it to JavaScript, you can compile it to Android devices, to native devices, to WebAssembly. And so it is one language that kind of rules all, and you can just use it as a common language for full stack development if you really want to. Well, it also is, interesting enough, truly a it's a multi-paradigm language. So in a way, Kotlin doesn't tell you what you should do. It treats you like an adult. And it says, you decide the paradigm of programming you want to use, and we're going to make it really simple and easy and elegant. So if you say, I want to use functional programming, it's really charming to do functional programming in Kotlin. But there are times, honestly, when we do want to write imperative style code. And Kotlin doesn't punish you for choosing that. It actually makes the code really elegant, so you can actually write imperative code, which is a lot easier to write in Kotlin than in other languages. Well, Kotlin is a static type language, or statically typed language, so you get really good type checking from the language as you would expect, just like programming in Java or C# or C++, or even to the extent where you have type inference like modern versions of C# and Haskell and stuff like that. Well, it compiles down to Java and JavaScript, like I said, but one of the cool things about Kotlin is it is extremely fluent. And once you start writing code in Kotlin, it just feels right. You're not fighting with the language. It tends to really make good sense when you write the code. It's very elegant. It is really enjoyable to write the code in this language. Let's take a look at an example to see how we can do it. So I want to start with a little example of a sample.kt. So KT is the extension for Kotlin files. So let's go ahead and start writing the code for Kotlin. Now, if you've ever had a chance to teach Java to somebody, anybody? Maybe unofficially, we all have done that, right? And what did you tell them? I'll teach you Java. And they said, is Java really simple? You said, of course it's really simple. Every book tells you that. And they said, why don't you teach me something simple? And you said, why don't I teach you hello world? And they're like, yes, that's great. And what did you do? You said public. And they said, excuse me, what's public? And your answer is, you don't need to know that right now. And they take notes, isn't it? Then you said class, and they said, what's a class? You don't need to know that right now. Then you said hello world, and there's a glimmer of hope in their eyes. It's like, yes. And then you put a little curly, and they're like, okay, what's going on? Then you said public. They're about to ask a question, but their note said, you don't need to know that right now. And then you said static. And now they ask you, is that also something I don't need to know right now? Now, this is called ceremony, isn't it? Now, to be fair though, JVM says you cannot run a piece of code unless you have a public static void main in a class. But guess what? That's JVM's problem, not your problem. And Kotlin doesn't want to take you to the problem. And Kotlin says, do the minimum you want to do. So what do you want to do? Oh, I want to write the main function to run the code. Well, then write the main function. How do you write it? You say fun main. And that's important in Kotlin because they want you to remember to have fun every single time you write code. So functions start with the word fun, and so you say fun main. And you realize that, you know what, I don't really have a need for the argument. Well, if you don't have a need for it, why bother saying it? You don't even have to say it. If you need it, say it. Otherwise, you don't have to worry about it. Then I'm going to say print line. Well, you don't have to say system.out.println because where else have you seen println ever? And then, of course, you can specify hello, and that becomes your code just as an example. So we wrote a minimum code in here in the KT file. So what am I going to do next? Well, I'm going to go to the command prompt right here, and I'm going to say Kotlin C. Oh, just like Java C, you have Kotlin C. But remember, Kotlin can compile down to Java or Java bytecode, or it can compile down to JavaScript or native and so on, or WebAssembly. So you have a JVM as an option. So you tag along your target to know where you want to target it to. And then, of course, this is going to be the sample.kt file. I'm going to just compile it. And when I compile it, as you can see, it created the sample kt.class. Now, to be fair, of course, you didn't say what the class name is, so they chose one for you, which is based on the convention of the file name followed by the kt appended to it. And then, of course, they create a manifest info as well. And of course, if I want to run it, I'm going to say Kotlin, and then you can simply specify the sample kt, and you can run it. And so right there, we ran the code. But of course, you say, gosh, if it's going to be a Java bytecode, why can't I just run it like a Java program? Well, sure, you can. So Java, and of course, minus class path, the current directory, and then I'm going to say sample kt, and I'm running that as a Java program because we compile it to Java bytecode. And obviously, if you're going to be using something special in Kotlin library, you can say minus class path, the current directory, or wherever the stuff is, and then you can append to it the path where the Kotlin standard library is. Just like we include other jar files, you can bring them in as well. So this shows us that you can write the code in Kotlin, but you can compile it down to Java bytecode, and you can run it as you can see here. So that becomes really easy. But of course, while you can run the code like that, there are quite a number of other options as well. I am a huge fan of REPL. And a REPL stands for read, evaluate, print loop, because to me, REPLs are a great environment to try out some little mini experiments. So I consider that as a micro prototyping environment. So you can just run the same command without the file name, and it turned into a REPL, as you can see right there. And now within the REPL, I can say, for example, 3 plus 5, and it gives me a result of 8 as well. So you can try out a little bit of a code example right here within the REPL. But having said that, though, I'm going to go ahead and delete all the stuff we wrote so far. So I'm going to get rid of those. And now what I'm going to do here is simply create a file called sample.kts. So I add a little s to the extension. Well, Kotlin, not only can you write code like you do in Java, you can also write a script in Kotlin as well. So if I create a script, I can just get down to the minimum even further and don't have to write even a function. So when do you write a script? Write a script if you want to do some really small task. If you want to build an enterprise application, create the traditional files and compile them. But for little things, we often do little system operations, you can write them in Kotlin. Well, the benefit is you don't have to learn different syntax and different shell commands for different operating systems. You just write the code once and you can run it on multiple operating systems as well. So that becomes a script. With one simple difference though, oftentimes among some programmers, the word script has a negative connotation. They frown at us when we say we write scripts. Well, Kotlin script is compiled in memory and executed. So if you have any error at all in the script will not run, period. So you don't have the risk of code running partially and then failing right in the middle. So it's all or nothing. It's going to run if it's correct, otherwise it's going to bail out. So in this case, I'm going to go ahead and run the script. How do I do that? So again, Kotlin c.jvm, but this time I'm going to say dash script, and I'm going to specify the sample.kts as the file, and it compiles it down and executes it, as you can see. So that's an example of running it as a script. And that's what I'm going to do for most of the talk because it's so convenient. So I'm going to just write the script here and then run it within the editor. Oh, talking about which, I want to quickly emphasize it. Well, Kotlin was created by JetBrains, and I would say JetBrains is probably the best IDE ever, hands down, isn't it? Pun intended, I often tell developers there are only two kinds of programmers in the world, those with idea and those with no idea. So I really love IntelliJ, and I want to be honest about it. But at the same time, I want to emphasize there is a bit of a suspicion among programmers, at least some programmers who say, oh, they created a language because they want you to buy their IDE. And that's why I want to emphasize I'm not using IntelliJ at all here. You don't have to use IntelliJ to do Kotlin programming. I mean, I hope you do, but you don't have to. That's a choice you make, which is independent of the language you choose. And as you can see here, I'm not using IntelliJ. I'm just using a plain editor. And you can run code with an editor. You can write code with an editor. You can use any IDE that you want to use. Kotlin doesn't force you to use any particular IDE or a particular editor. And so you can choose whatever you want to choose. So right there, I've written a little piece of code and I executed it within this as a script. So we saw the ability to write the code and compile it and execute it. We saw how to run it as a REPL as well. And then, of course, we saw how to run it as a script. So let's move a little further from there. Well, a few nice little things in Kotlin. Well, the very first thing in Kotlin is semicolon is optional. I mean, you saw that a minute ago. I did not put a semicolon in the very end. Semicolons are absolutely optional. So when you start programming in Kotlin, your right pinky actually shines a little bit because it's not doing that stupid semicolon over and over. So it can actually be used for more useful purpose. So you don't have to put a semicolon. Now, obviously, you may ask the question, is that such a big deal? And I would say it is huge because when it comes to creating DSLs, and Kotlin is a really good language for creating internal DSLs, it's a beautiful language, but semicolons disrupt the flow oftentimes. So if a language requires putting semicolon, it's not as suitable for creating DSLs as you would a language which doesn't require that. So from that point of view, I think this is brilliant. Well, secondly, it gives you sensible warnings. Well, Kotlin believes in failing fast and failing early. So if you have a piece of code that it suspects may lead to a confusion or an error, it gives you a warning pretty quickly. And for example, if you have a variable you have not used in the code, it'll give you a warning that you're not using that variable as one example. So one of the things I follow in development in general is this principle of treating warnings as errors. So I often configure my build system, my continuous integration system or Jenkins to fail if there's a warning. So in the case of Kotlin, you can run it with a -w error option. So if there were a warning, the build will actually fail. So you can actually fix that and move forward and make your code a lot more reliable. Well, Kotlin also has a really healthy dose of type inference. So what is type inference? When you create a variable, you can create a variable, for example, like this. You can say string is equal to hello, and then I'm going to print the value of greet, as you can see right in here. Now, obviously, the greet is a string because we defined it as a string, But at the same time, though, notice how we define this variable. We did not put the type and then the variable name. We reversed it from the Java point of view because Kotlin wants to emphasize the variable names are absolutely important. You know, how many times do you see where people do a string and this beautiful variable called x? And if you tell them not to use x, they use a p or a k or a w. It's insane. Well, Kotlin wants you to think about good names for variables based on the context, based on the domain. And the type is secondary compared to the variable name. Now, in this case, if I were to say greet is equal to 1, I want you to notice the error that you are getting at this point. Ignore the first error that you see up here, because the first error is complaining I cannot modify greet. But look at the second error in the bottom. It says error, the integer literal does not conform to a type expected. Well, keep that in mind for a minute. Now I'm going to go back to this code right here, and I'm going to remove the type information from here and execute the code. Now, what is the type of greet? Make no mistake, at compile time it knows the type of greet is a string. And that is basically type inference. It looks at the context and determines the type for you. So as a result, if I were to go back here and say greet equal to 1, notice the error that you get is exactly the same as before. It says the integer literal does not conform to the expected type string. So it is type inference. And so as a result, you don't have to waste your time saying what the type is when it's absolutely obvious. Not only can you use type inference for local variables, you can use type inference for function return types if the function is relatively small, that is, it's a single expression function. If a function is really large, Kotlin doesn't want to infer the type, not because it can't, because it doesn't want to, because it can be really confusing for the developers to know what the type is. They emphasize that you provide the type. Similarly, I think that Kotlin doesn't go overboard. I'm a huge fan of languages like Haskell. Don't get me wrong, I love those languages. But one thing that scares me in Haskell is Haskell will infer the type of your function parameters if you don't specify that. And I'm not really a big fan of that particular feature because I consider the interface of a function to be sacred. I don't want the implementation to vary the interface. So Kotlin says, you know what, you need to tell me what the parameter types are so they don't go overboard with this idea. Now, having said that, how do you define a variable? You can define a variable, for example, max equal to 1000, and I'm going to print out the value of max over here, and you can see the value is max. But if I say max equal to 1000 one more time, notice the code gives me an error. And the error says that I cannot assign or reassign to a val. So val is much like our final. But it's much better than final because if you're programming in Java, if I want to know what your variables are final, that's very easy. I just grep for final. But if I want to know what variables are not final, how in the world do you grep for what doesn't exist? That's really hard, isn't it? Well, in this case, you can quickly find out what your variables, which variables are final and not, because all you have to look for val versus you can look for a var. So what is var? Well, in Kotlin, they want you to use val most of the time. And the times you don't use val, they want you to think about it and come back and use val. So val is the preferred approach, but there is an alternative which is called a var. So what is var? Var is called the keyword of shame. So if you use var, you cannot make eye contact with your colleagues. You're walking down the corridor, you're looking at the floor walking, they know you use var in the code, and they will follow you and help you refactor it. So var is a mutable variable, and as you know, mutable variables make the code hard to reason, hard to work with, hard to make it concurrent. So many other problems arise from mutability. So they want you to use immutability as much as possible and mutability really less. Now this, I think, is a bit of an effort to transition for us, the Java programmers, because in Java we are used to creating mutable variables all the time. Well, when it comes to Kotlin, I'll be honest about it. I put a lot of var as well, but thankfully there are people around me who will kind of look at me and say, really? And then I would refactor the code to remove the var and make it a val. So you want to get into the habit of using more val instead of var as much as you can. Similarly, you can start using string templates to really provide a fluent expression. So for example, if I say name is equal to, let's say, Greg over here, and I'm going to go ahead and print out, say hello, but then I can put a $name and I can just execute that code very easily. So this becomes a really easy way for us to embed expressions within strings as well. But of course, if you really wanted to put a little bit more complex expression, you can put a little curly, and then of course you can put the length after this. It does require that you spell length properly though. And then of course, when I run this code, you can see it says, hello, and then 4 in this case. So you can see that you can put expressions in here as well. And that becomes a nice little string template. Similarly, you can create a multi-line string as well. Simply put 3 quotes and start writing multiple lines of string. You can put expressions in that as well. But what if your string is situated within maybe a function, or even worse, within an if statement within a function? Well, then you're going to have multi-levels of indentation, which you probably don't intend to carry forward. Well, you can use a trim margin to remove that indentation, or you can specify what character to look for and remove that particular indentation. Well, that kind of comes back to one other thing I want to conclude this part with, and Kotlin wants to favor expressions over statements. Now, if you look, so why is this the case? I want you to think of a statement for a minute. Just try this for a second. Say the word statement. It's like life was taken out, isn't it? It's so grim, a statement. I don't like the word statement at all, honestly. Because what is wrong with the statement? You call a statement, it performs an action, and you say, thanks statement for doing it. What was the result? And the statement says, I won't tell you. You go get it yourself, isn't it? So by definition, statements cause mutation. And side effect. So the only way you can use a statement is by mutating data or causing side effect. Now, think about this for a second. In functional programming, you don't want to create side effects. You don't want to use mutability. So if you analyze functional programming languages, the true functional programming languages, those don't have any statements at all. So languages like Haskell and Erlang don't have any statements. Languages are only made up of expressions. So what if a language is made up of only expressions? Well, Kotlin is not a functional programming language. Kotlin is a hybrid programming language. So it doesn't go all the way to that extent, but they do have more expressions than statements. So you don't have an if statement, you have an if expression. So as a result, you can use the if to return data from your expressions, and as a result, you can assign it to a variable, which is an immutable variable, or you can return it put a return if as well, and things like that. Of course, be careful though, not everything is an expression. In Kotlin, you got to know what is and what is not. If is an expression, try is an expression, so the last statement or last expression within a try is what gets returned, or at the same time, if there were an exception, the last expression within a catch becomes the result of the try and catch, so you can use that pretty nicely. Well, let's move a little further with this. Oh, by the way, if you have any questions, please don't hesitate to ask along the way. I'll be delighted to hear what you have to say. Yes, please.
Could you demonstrate the trim margin?
Yeah, so the trim margin basically is, if you were to put a function, let's say, for example, I write a function foo, you can pretty much say in here, val stir is equal to, and you can put a multi-line string that can run to many different lines of code. So if you were to write these lines, what's going to happen is that margin, unfortunately, becomes part of the content. So what you can do is you can simply call a dot trim margin right there and say, well, I want you to remove the margin. So this multi-line string you are creating, obviously, this is going to run into multiple lines, and you're saying, strip out that margin for me. But what if you wanted to use a particular character? In this case, of course, the default character is a vertical bar. But what if vertical bar is part of your text itself, or you have some other meaning for it? Well, then you can say, I'll choose something else, maybe a tilde. And then you can come in here and say, well, use the tilde as a margin, for example. So you could build with that to just strip out whatever you want to strip out. This is only useful when you have an indentation. If it's a top level, you don't have to bother with that. Yeah. So with that said, let's talk a little bit about functions. So how do we write functions? Well, functions and methods are both written with the keyword fun in front of it. Well, you can use return type inference for functions, or you can specify the return type if you want to. Now, what about void functions? Well, because Kotlin wants to treat everything as expression, there is no void in the case of Kotlin. So what if you call println, for example, which is a void function in Java? What's going to happen? Well, Kotlin treats a unit type instead of a void. So unit is the return type of void functions, and because it's returning a unit, it becomes an expression. So unit represents void in the case of Kotlin. Let's take a look at one example here. I'm going to print out greet over here, and I'm going to say Jane, for example. So what does the greet function do? The greet function simply returns, let's say, hello, dollar, let's say, name over here. But what is the name? The name is going to be a parameter with the value type of string in this particular case. So when I run the code, the parameter type is a string, but what about the return type? The return type is inferred because this is a single line expression. So a single expression function. So if the expression is extremely small, then you can infer the return type. If you were to put a curly and put multiple lines of code in the curly, or even one line, then you have to put a return and you have to specify the return type. If you don't say the return type and use a curly, then it becomes a void function, a unit returning function. So you can either write the code like this. As you can see, it inferred the return type to be a string. And just to illustrate the point, if I were to say val result, which is a string, again, you don't have to say string here, it can be inferred, and I'm going to just print out the result right in here. And as you can see, the code actually is quite fine. But if I change this to an int here, you'll get a compilation error, obviously, because the return type was inferred to be a string. You cannot assign it to an integer, obviously, and that gives you an error. But of course, you can entirely leave that out, and the type inference kicks in all the way through. Alternatively, you can go in and provide the return type. Obviously, this is wrong because the type of the function is a string return value. You cannot assign an integer to it. But of course, if you put a string, then everything is in harmony, and it simply works, as you can see. So that's an example of how you can specify the return type if you really like to. If you do specify the return type, you do have the option of specifying a little curly, and then of course you put a return at this point, and then you close that curly, and that becomes a regular function. This is a multi-line function, not a single expression function, and you can go that way also. Of course, be careful not to leave out this colon string, and if you do, that becomes a function that returns a unit, and then of course you put a return of a string, it's going to give you an error to tell you, hey, you're telling me you're going to return a unit, but you're returning a string, what's up with that? So that's going to be an error at that point. Well, going a little further, there are some really beautiful features in Kotlin. One of them is default arguments. Step back for a second and talk about Java. Well, in Java, what do we normally do if we want to vary the argument that we pass to a function? Well, for example, maybe what I want to do is to call the greet function and send Jane like this, or maybe I want to say Jerry, but I want to also call the greet function maybe later on and say Jane and pass maybe howdy. Well, in this case, I want the old code to continue to work, but I want the new code to take in an additional argument when I call in. So people who have written the code already don't have to go back and change all that code. They would have to recompile it, but they don't have to change it. Well, but how do we do that? Well, you can achieve this by using what is called a default argument. So you can say message colon string, and you can say equal to, and you can provide a hello, if you will. And then, of course, you can then write the function to say, this is going to be the message that I want to use. So existing code is going to continue to work, and the new code can pass in the new value to this particular function. So what you can do is to provide additional parameters with default arguments to this particular function. Now you can write as many default arguments as you like for the function as you may choose. But if you do, this is not just a default value, this is actually a default expression. So for example, you can go back to this code and you can say hi, and then you can put a dollar, for example, name.length. And this is a really geeky way of saying hi-fi to Jerry. So you can run the code that way also. So an argument can actually use the parameters to its left if you really wanted to, and this gives you quite a bit of flexibility, as you can see, in writing the default argument. So the default argument is actually an expression, not just a value, and that is the power you get out of this, and that's pretty powerful to extend the existing code to introduce default values. But I have to say, one of my favorites is the named arguments. Now, why is a named argument so important? Well, one of the things we carry about a lot is readability of code. And when you're reading the code a lot of times, you're probably not reading the code when you're having a great time. You're reading the code because you're not sure what the code is doing. And the worst way to write a code is to make it really cryptic, where the programmers take the beating and the suffering. So if you look at a function like, for example, let's say create person, and the create person takes a name which is a string, and then it has an age which is an integer, and height which is integer as well, and then it got a weight which is an integer. Now, because, and of course all I'm going to do here is simply say print line, let's say called for a minute. Now, sorry? Okay, so let's fix it. Are you happy now? Okay, so so let's go forward here. So in this case, of course, when I take this particular code, notice it gives you warnings. That's what I wanted to show you first. It tells me I'm not using name, I'm not using age, and so on. Well, that's the warning coming in to tell me, hey, are you not supposed to be using these? What's up with that? Well, let's go ahead and put the name really quickly here, age, and then maybe the height value, and then of course the weight as well. And of course it's not going to complain anymore. But then I'm going to call the create person, and I'm going to say Sam, comma, maybe I say 12, and I say something like 100, comma, 50. Now, if you were to come in and look at the code, clearly this is not going to be in front of you when you're looking at this code, because the code is defined someplace and used in another place. And you look at this code, and I am absolutely sure this is going to cause you some frustration, isn't it? Because you look at this code and say, what in the world do these 12 and 150 mean? Because we don't have a clue what these numbers mean in this particular context. Well, this is not a good way of writing code because it increases cognitive load for the programmers. Wouldn't it be so great to say age is equal to 12, and then simply say, for example, weight is equal to 50, comma, height is equal to 100. Just to emphasize, you can put them in any order you want to put them in. So when I run the code, of course, it becomes very expressive. And just to illustrate, I did not put name equal to Sam. You could have. So you are absolutely able to mix and match things. You are able to put the positional arguments and then suddenly switch over to using named arguments. And if you had maybe a default value of some sort here, maybe you say 50 is the default, guess what? You can even leave that out if you really wanted to. Nothing stops you from doing it. So you can start mixing and matching all these ideas. I do have to say, this is, among a lot of other things, this is one of my favorite features. For example, when it comes to using coroutines, I was calling the with context function, and the with context function literally can take 3 or 4 different arguments. And the problem is, I know what arguments it takes, but I'm not smart enough to remember what order to pass them in. So guess what? I can just give the name equal to value and be done with it, and I don't have to give all of them because every one of them have default values. So I can pick and choose what I want to provide, and I can easily get away with writing minimum code, and I can come back and change it really easily. So that becomes really nice to work with as well. So absolutely a really wonderful feature. You can mix and match it. Similarly, you can also write a function with var args. So you know var args in Java, it's a very similar concept here in Kotlin. When you create a var arg, it synthesizes an array of the type. And then, of course, if you want to pass to a var arg an array itself, you would have to use a spread operator, which is an asterisk, and explode that particular collection and pass it. So I'll pass that particular idea here because it's a lot similar to what we do in Java with a few variations. Yes, please.
Is that similar to Python where you spread the keyword on it?
So you put a star to spread it. Yeah, so just a star to explode it, yeah. And of course, let's say for a minute that you want to write code to process a collection of data. Now, I would say I really like functional programming, and I'll admit that. I love to write code in functional style. But at the same time, I want to say there are times when I do want to write imperative code. And I don't want the language to force me to do it one way or the other. I want the language to treat me with respect and say, you make your judgment and we'll work with you. Now, not only does Kotlin allow me to write imperative style code if I wanted to, they don't punish me for writing it. They make it really fluent. So let's take a look at an example of how we could be writing this. So I want to do a really small for loop over here. So I can say for some variable x, and I'm going to say in 1 to, let's say, 10. And I'm going to simply print out the value of x right in there. That becomes a range, and I can iterate over the range of values. Notice in the output does include the value 10 as the result. What if you don't want the 10? What if you want to stop one shy of the value 10? Well, then you can say until 10 like this. And when you run the code, you can see it does not include the value 10. Now, that worked, but that leaves me a little unhappy because the code is a little noisy. And I want the code to be fluent. I want the code to be, one of the things I care about a lot when I work with programmers, when I do code reviews, I often tell programmers the most important line in your code is the blank line, because the blank line gives a breather. And I always tell my developers, if you put a blank line, that's how you show respect to the reader of your code. When people write code like there's no tomorrow, that is really hard, isn't it? You start reading it, and your blood pressure keeps going up. And this is a great research project, actually, if somebody wants to do it. Hook up medical devices to people as they do code reviews and see how they feel about it, isn't it? So to me, a little space gives me breather. And I'm like, this feels good when you're reading the code. Wouldn't it be nice to say a space until, and not having to put that stupid parenthesis around it, and you can run the code? Sure enough, you can do that as well. Not only can you do that on this code, you can do this on your own code as well, because all you have to do is create your functions as what are called infix functions. I'll talk about this more when we talk about fluency later on, so I'll come back to that, please. Bingo. Until is a method. Oh, it's a beautiful question. Until is a method on integer. One of the things I want to emphasize, and thanks for asking that, because Kotlin does a lot of stuff for you, and an immediate concern among programmers is, oh my gosh, we're going to incur the auto-boxing overhead. We're going to have poor performance if we do this. And this is the brilliant part of Kotlin. What they did is that until is an extension function on integer. It's not a function, it's not a method, it's an extension function. I'll talk more about extension functions later on, but at compile time, what they literally do is util is a static method in your package where it's defined in the standard library. So technically speaking, what happens is it turns into a 1, 10 at compile time, so you're not incurring an overhead. At the bytecode level, you have no boxing overhead because that's still a primitive integer, not an auto-boxed integer. So that's why those questions are extremely important. In fact, I'll mention this as a good exercise to do, and that's what I decided to do in the book as well, is to, at some points in the book, I pause and generate the bytecode, and I show how the bytecode looks, and I encourage programmers to actually do it. Because when you're looking at a Kotlin code, it looks so fluent, you doubt that it's going to be good in performance, My recommendation is compile it in bytecode and take a look at it. I guarantee your mind will be blown because they actually preserve performance, at the same time give you fluency in your code as well. So absolutely wonderfully done. I have the deepest respect for what they have done to provide that kind of flexibility. So that's what is happening in this case, is that it compiles down to an extension function. So you can do this, but what if I don't want all the values? I can do a step 3, for example, and then of course I can start skipping the values as well, and that becomes really fluent, as you can see. Now, what does it create? It creates an int progression object along the way, and it's the int progression object that you're iterating, because that implements the iterator that you're really using at that point. So we saw these kinds of methods. Similarly, you can count down by using a down to method as well. But what if I really want to loop through values and print them? Well, let's give it an example here. Suppose I say names is equal to list of Tom, comma, Jerry. And I want to iterate over Tom and Jerry. This reminds me of an experience I had. I'm not even kidding with you. I called the support line and I said, may I speak to Tom, please? Without missing a beat, this guy said, Tom is out at lunch. I'm Jerry, may I help you? Seriously, I hung up. I mean, what are the chances Tom and Jerry work together in a company in support? This is a conspiracy, I think. But anyways, coming back to this code, I'm going to say for name in names, and then I'm going to simply say print out the name right there. Now notice the elegance of it. We're not doing I equal to 0, I less than, and then stop and ask the question, is it less than or equal to? You don't have to do any of that. But having said that, we do want the index from time to time. So if you do want the index, what do? Well, if you really want the index, you can go to this function and say with index, and you can call a function that gives you the value with the index. Now, obviously, what is it? Well, that's going to be called an entry, and I'm going to go ahead and print out the entry value right there. So good news, you got the index value along with the value. Bad news, how do we extract the index separately from the value? Well, therein comes another beautiful feature in Kotlin, and that is called destructuring. So what is destructuring? Well, structuring or construction is taking properties and creating an object. Deconstruction or destructuring is the reverse of it. So you take an object and you tear it apart into pieces. So what I can do here is I can say that I want an index I, and I want a name to be given to me. And I'm going to print the value, let's say I, and then maybe a few dashes and print the value name, if you will. And so I can start using destructuring very easily as well. So you got the best of both worlds. You don't have to endure the pain of iteration, and you can do very fluent iteration here, as you can see. Now, having looked at this, let's go back to this one more time and ask one question. If I said name over here, and then of course, if I were to write this code, it's going to print the value of name right there, but that makes me a bit curious. I'm looking at the name, but I did not say val or var. Any guess what it's going to be? A val, of course, isn't it? It's a val. You don't want it to mutate. Now, can we think of a use case where we do want to mutate that variable? That use case, there's only one use case. It's called insanity, right? There's no other reason ever to do it. So in the case of Kotlin, you cannot put val over here. Why not? Because what else do you expect? So it gives you an error. And don't even try putting var, you're going to make it really angry. So you cannot put anything because that's the only sensible option. It is immutable. Same thing with function parameters as well. I mean, how many times you write a function in Java and then somebody mutates that parameter and you run over to make it a final? Well, why would it not be final? So parameters are always final by default. You cannot make them non-final. That's the way they are. So val is going to be the case for functions parameters as well. With that said, I want to talk about argument matching, and this absolutely is beautiful. Yes, please.
Sorry, all parameters are vals?
When not used in a constructor scenario, all parameters are vals. Yep, that's the way it behaves. And it's very opinionated in that regard. That's the way they want you to use it as well. Yeah. Constructors are a little different, and we'll see why a little bit later. So given that, of course, let's talk about the argument matching. So let's think about this for a minute. I'm going to call process right here, and I'm going to print out the result of process, and I'm going to pass a 1 to it. Let's also call this with maybe a 14, maybe a hello, and then maybe one more, 1.5. Now, I'm calling a function called process. What does the function process do? The process function takes an input, and this input is any, meaning it could be just about anything. Now, I'm going to talk about a when. Now, before I talk about when, this was a few years ago. I was working with an application written in Ruby, and I was the only programmer on this application. So there was one thing I knew. Nobody else would ever look at this code. But there was one problem. I knew I was going to look at the code the next day, and I know I'm not going to be happy looking at it. And what I wrote was a series of if-else statements, and it was absolutely ugly. And I immediately stopped it and said, you know what, my tests are passing, but this if-else is really ugly, I'm going to fix it. And I started looking for a solution, and I found this beautiful thing in Ruby called when. So you can say case and maybe an expression, and then you can say when and give conditions, and every when becomes a beautiful branch, and the code just shrinks and becomes really, really elegant. I've used that ever since, and so when I program in a new language, I always kind of look out for things like that. So I was very happy that there was when in the case of Kotlin. When comes in a couple of different flavors. When is a statement, but when is also an expression. So if you really wanted to, you could say when input and make that a single expression function. The result of the when becomes the value that you're going to pass to it. So in this case, I can say if the value is 1, I'm going to return a 1. And what if it is not? I'm going to say else. I'm going to say whatever. So in this case, if I run the code, you will notice that it's going to tell you 1 for the first one and whatever for all the other things. If you use as an expression, the else part is required to handle what you may not have considered, and there are some variations depending on the type you are looking for. But one of the things you can do in here is you can come into this code and say in, and you can say 13 to 19, and you can specify a teen. And that's a beautiful syntax to look for a range or a value in a collection. So if you have fruits, you can say, is the given value a fruit in this collection of fruits? You can look that very quickly. And as you can see, it says a teen for the second call. Similarly, you can say is a string, and then you can specify got a string. And when you run the code, you can see it tells you that you got a string. Now, while we are at it, let's talk about something a little different. Let's switch gears to Java for a minute, if you will. So I'm going to say in Java a public static void process function, and the process function takes object input. And then what am I going to do within this? I'm going to say if the input is an instance of string, then I'm going to simply say output got a string. Else I'm going to say, something else. Who cares right now? We'll put something here. Now, given this code in Java, what I want to do is not just print got a string, but I want to say what the length of the string is. So I'm going to go ahead and write this code. I'm going to say got a string of length, and then I'm going to say plus, I'll say input dot length. Would that work? No, because I have to write some beautiful code here. I got to put a little parenthesis, and then I have to put a string right in here, isn't it? Now, anyone remembers what this feature is called? They call it casting, I call it punishment. Because you already asked the question, is it a string? Can you imagine talking to a human being like this? You say, is it a string? What's its length? Of what? Right? So this is not a conversation you're going to have, isn't it? They're not going to be a friend for too long if that's the way they talk. Because you want people to maintain a context. Well, Java doesn't maintain the context. You say, is it a string? It says yes and completely forgets it. And now you have to cast it again to get through. Well, but this is a punishment because it would be really nice if the language is intelligent. I've got a good news for you. Java is going to change this in the future. Just don't ask me when. But it's going to happen. And when Java changes, here's what you're going to see in Java as well, what I'm going to show you here as a feature called smart casting. So what you can do is you can go in here and say a $input.length, and you can say length right here, got a string of length, and then you can simply use a smart casting. Now, make no mistake, you cannot do input.length anywhere that you want to. So for example, if in this case you had said a string and then you had written the code like, for example, val result is equal to, for example, and then you put this when block right here, when expression right here, and then when you finish it off here, if you were to come in here and return, let's say this particular value, let me try to work my way through this, and I'm going to simply say return result at the very end of this. So when I run the code, it's going to give you that result. But if I were to go back here and say print line input.length, that will not compile, obviously. Why? Because the any doesn't have a length, so you couldn't do that right there. So in other words, this is an error, obviously, because input is not a string, but this is perfectly okay because within this branch, you know it is a string, and so it's very intelligent. That is smart casting right there at work, and that's what you're basically seeing at this point. So we saw the power of the when or the argument matching along with the auto casting as well. Well, that takes us to the next one, which is the null type. Now let's switch gears for a second and talk about effective Java. What did effective Java tell us? Don't return a null, instead return an empty collection. Absolutely wonderful advice. I couldn't agree more. But what did effective Java tell us in the past about returning a single reference if you don't have something to return? Well, we often returned a null. Now, when you return a null, there are two problems. Your code is not really telling the intention very clearly. A user of the code may not expect a null. And if they are not expecting a null and they receive one, they get a null pointer exception, which is really not a good thing. On the other hand, if they are expecting null and you won't return a null, they become overly defensive and write a lot of ugly code with all those checks, which is not a fun way to code. Well, what did Java 8 do? Java 8 introduced optional of type T. Well, there are three problems with optional in Java. The first problem is, if you write a function, let's say foo, and I'm going to return, let's say, an optional of string. Well, what are you going to return from here? You may return an optional of some data or an optional of empty. Well, the first problem is optional is a wrapper. So as a result, rather than returning a simple reference, you are returning a union object every single time. So as a result, there is a small overhead in this case. So that's one problem. The second problem is, if you provide a certain solution, there will always be a programmer who surprises you and does things you never expect them to do. I'm not kidding with you when I say it. I've come across programmers who literally said, return null here. And this is like absolutely useless. But they're like, I can return null. And you kind of scratch and say, please don't. There is no discussion anymore on this one, right? And the third problem, so this is the second problem is they may return null. And the third problem is Java does not stop stupid people, right? So that is the third problem in this. So if you're going to return a null, Java is not going to tell you, please don't. And what's going to happen? Your code is going to blow up one more time, which is kind of sad. Hopefully there's a code review and somebody takes that person and says, we never do this. Raise your hand and promise you will never do this. But it would be ideal if Java didn't permit to do it. Well, what if the language can give us this guarantee? So what if the language says, hey, this function will never return a null, I know it. And as a result, you never have to perform null check. Or the language says, hey, there's possibility of a null here, you better perform null check, and I'm not going to give you value without it. Well, that is exactly where nullable types come in. So what is a nullable type? For every type P, there is a parallel T question. So this is called a nullable type. So if you were to use an int, you have an int question mark as a nullable type. So if you want to return something that would not be a null guaranteed, return a non-nullable type. If you think there may be a null, possibly return a nullable type. Now what is the benefit? The benefit is the compiler will enforce this for you. So here's a really quick example. I'm not suggesting you return null, but if you have to return null, there is some help here. So I'm going to create a nickname function, and the nickname function takes a name as a string. And what am I going to do in this function? I'm returning a string right in there. I'm going to call nickname and pass Robert over here, but I'm also going to call nickname and pass Venkat. Now in the code I'm going to say if the name is equal to Robert, I want to then return maybe Bob. But what if the name is not Robert? Oh, quick detour. A double equals is actually the right one to use in the case of Kotlin. That maps over to a dot equals method with some other safeguards built into it, so we are pretty okay here. But I return a null right now. Well, this code will not compile. Why not? Because when I compile the code, the compiler tells me on line number 10, line number 6 rather, it says, null cannot be a value for a non-null type string. If I really want to return a null here, I would have to put a question here to say this possibly is a null. So if I run the code this time, you can see that in here it says Bob and null. Now on the other hand though, if I want to process the value that we get, so in other words, what I'm going to do is remove this for a second. Let's simply say, dashes for a minute, we'll come back to this. But I want to get the result, and I want to print the length out of this right here. So when I run the code, you can see it prints a 3 and a 3 for the length. However, if I put a question over here and return a null, we're going to be in trouble if we call a dot length, isn't it? Because the length is going to be called on a null, and when you call something on a null, you end up with a null pointer exception, which is not going to be fun. Please. A little louder, please. What? Oh, so if you call nickname with null, it'll be a compilation error because this is not a nullable type. So you get a compilation error as well. So in this case, the code will not compile. Why? Because the compiler says, hey, you cannot use this because it's possible that value is null. So what can you do? You can do a safe navigation. So I'm saying if the value is not null, then call the length property. If the value is null, just pass it on forward to the caller. So when I run the code, you can see it printed 3 over there and a null over here. But of course you may say, gosh, I don't want to print a null. If the nickname is not there, I want to return a 0 as the length. Well, sure, for that you can use a colon. Notice you used a colon dot as a safe navigation. Here you say question dot versus a question mark, a colon, and then you can specify a value of 0. So what this means is, if this is not a null, then return it. If this were a null, then substitute with the default value, which is 0. So when I run the code this time, you get a 3 versus a 0. Now this operator has a special name. That name comes because somebody had a weird imagination and a lot of time to waste. So if you want to tilt your head this way and look at it in your head slanted, what you're going to see is beautiful eyes over there. And this is nothing but the hairstyle of Elvis. So this is called the Elvis operator. Trust me, that's what somebody thought about it. They called it Elvis operator. Well, it's as cool as Elvis, isn't it? So it prevents this null pointer exceptions, and it also gives you a substitute value. So this is a very safe navigation. One final thing to go back and talk about what you asked a minute ago. If I were to call nickname and pass a null to it, I get a compilation error. And of course the error because you're not allowed to pass a null for a non-nullable type. If you put a question mark right here, then that is perfectly fine. You can pass a null, but within your code, you got to be careful about it. So if you're going to get something from the parameter, for example, name.length, if you're accessing it, you no longer will be able to do it. You will have to say a question dot and be defensive about it as well. Now, having said that, I want to mention just for a minute. Now, once again, going back to your earlier question, are we really posing a problem here in performance? Well, this is another thing I'm truly appreciative of what Kotlin did. So if you generate a bytecode of this code and take a peek at the bytecode, you'll be surprised. In the bytecode, this will appear as a string, and this will appear as a string as well. So they wipe out the nullable types at compile time. So the bytecode is the same bytecode as you would generate in Java, except the JVM bytecode is amazing in terms of its capability. Imagine you have a bookshelf and you have books in your bookshelf. But what you can also do is you can take a post-it note and put it on the bookshelf itself, and you can do some annotations. Well, bytecode is exactly like that. A bytecode contains a Java bytecode, but it can also carry metadata on top of it. Think of these like post-it notes. So Kotlin exploits these metadata. So when you go to a function, you will see the Java bytecode along with the metadata. Obviously, this metadata is not known to Java compiler because Java doesn't have this concept, but the Kotlin compiler knows to look for it. So as a result, when you call this function from Kotlin, the compiler will look at the metadata and say, aha, that's a nullable type versus a non-nullable type, and do the proper processing for you. But you have zero runtime performance overhead, because once the bytecode is compiled, it's bytecode running. There's no overhead associated with nullable and non-nullable at all. So you have no a difference in terms of what the code is going to run at the time of running. So that is an example of how the nullable types work. And one quick note, autocasting works in this regard as well. What does that mean? Well, if you were to take a nullable type and then say nullable type, let's say val, let's call it as foo colon nullable type of some type nullable. If you say when foo, if you were to write a null and put an arrow, then you take whatever else, guess what? Here you don't have to use a question dot, because if you come to this path, compiler knows it's not a null already. So as a result, you don't have to really be defensive because the auto smart casting works just fine. Question, please.
Yeah, real quick. The example you had, line 3, where you use the double equals as overload the equal.
Yes.
If the argument type was null,
Bingo.
it's taken care of it and you don't have to write anything else.
Yes. That is because it's a nulless. So the question is, thank you. The question is, if you were to receive a nullable type, and if you're using a double equals, and you don't have to do anything extra, it works automatically. And the reason for that is the double equals is not just a dot equals method. It actually performs null check safely as well, and that's the reason it's taken care for you. Yeah, absolutely, you're right. So that's actually a good news. So you end up writing a lot less code as well. Absolutely. Yes, please. So the question is, in the case of returning an int question mark, is going to auto box it? No, because actually it is extremely smart to fall back on primitive types almost everywhere possible. And this is one of the nice things about extension functions is they turn into a static method. So it's a language actually built with this in mind. And don't get me wrong, I love a lot of different languages. But in the past, when I've seen languages do something like this, they went the route of auto-boxing. And Kotlin not only learned from the good things about other languages, they learned from things that were not done really well in the other languages. And so they actually took the time and effort to make it really performant. And that is one thing that's very important to keep in mind, is that almost every corner you turn, you get the benefit of the language, but without compromising the runtime performance. And they've really taken the pain to really do that.
Actually, in the Kotlin documentation, it will talk about that it does exactly that for just about every case except like int question mark. Because if you're returning an int question mark, it means that you have to be able to handle null, and there's no way to express a null in an int. So for that function, the API for that function declaration in the JVM, it returns back an integer.
I stand corrected, you're right. Yes, in the case of when you have the primitive type being returned, that's the catch, because int cannot be null. Thank you, I stand corrected for that. But of course, if you were to return an int, there's no overhead for it. Yeah, you're right. So with the question mark, you're absolutely right. That's the catch because int cannot be a null. Thank you.
If you're returning, like, instead of returning null, you're returning a Java function, is it going to default that to nullable or non-nullable?
So your function is returning another function, you're saying?
You're using a Java function from the library.
Oh, so Java functions are already written, so you cannot change anything from them. So on the Kotlin side, it will be treated as a nullable type because it potentially could be a null. Okay. Yeah, absolutely.
Except that a lot of, especially the JDK stuff, has already been, they've gone through and identified the places where it's nullable or not. So in most cases,
If it's annotated as a not null.
yeah, and so they've already gone through for most of the standard Java library and done that work.
Right, but if it's your own Java library code, yeah, exactly, yeah. Okay, so moving a little further, what about functional style? Well, Kotlin provides you as much of functional style as you would like to use. So in this case, of course, you can create lambdas, and the way you create lambdas is a lot like you do in Java, except use curlies instead of the parentheses that you normally use. It feels a lot like writing it in Groovy. So as a result, you could use, for example, it as a variable if you have a single argument. Not only that, you can use method references as well if you really wanted to. So for example, if you were to say, let's say values is equal to a list of, let's say 1, 2, and 3, you can say values dot, let's say for each. Well, in this case, you could specify maybe the value that you're getting. You could say print the value out, and you can ask it for the value to be printed out at this particular point. Alternatively, what you could do is simply say, well, it's a single argument. Why don't I just simply say an it? And you could use an it in its place as well. Or alternatively, what you could do is simply get rid of this whole thing, and you can use a function reference as well. So for example, a println right here, and then as a result in this case, it simply uses that. So you can kind of vary based on what you really like to do. Similarly, you could use a filter map and reduce. If you want to write a functional code, you can write functional code as well with that. So a few different features that I want to quickly mention here. Well, when it comes to lambdas, there are some flexibilities. If the lambda is the last argument, you don't have to put that into parentheses. You can keep it outside, just like you can do in Groovy. So these concepts are pretty much prevalent in Groovy. They've kind of made use of these features. But one thing that really blew my mind in the case of Kotlin is that you can actually define lambda expressions, receivers of a lambda expression as an inline. And if you define it as an inline, then instead of making a call to a lambda, the lambda gets expanded right at the call site. Now clearly there's benefits to it and pros and cons to it. The benefit is you don't have a runtime overhead. The disadvantage, of course, is your bytecode becomes bigger in the place we are calling. So when do you use it? Well, a couple of reasons to use it. If you're going to make this call millions of times and the performance is really critical, you can consider inlining it. As a bonus, you can also do return from within those lambdas, because now that they're expanded, when you return from the exterior function. So return can only be used when you have functions that have inlining, and there are a few rules surrounding that. You can take a look at it. Yeah, please.
Can lambda be assigned to variables?
You can assign them to variable, and if you do, you have to say what the type is. So in that regard, suppose I say, in this case, val, and I'm going to say is even. Well, there are a couple of different ways you can handle this. One way you can handle it is you can say that this is an integer, and then of course you can return from this n mod 2 is equal to 0, and then of course you can call the is even and maybe send a value 4, if you will, to perform this computation. So in this case you can say this is going to be an even value that you're going to receive, and remember you should use a curly, not a parenthesis or a parenthesis. So in this case that becomes your lambda that you're passing, and you got to say what the type of this is. That's one way to specify the type. Alternatively, what you could do is you can also say val is even, but then you can say that this is going to receive an integer as a type, and then the result is going to be a Boolean at this point. And then of course in that case you can simply say even it mod 2 is equal to 0, and then that's another way you could write it. But you need to say what the type is if you're going to assign it to a variable, because there's not enough context to determine the type at that point. So with that said, what about classes? Well, before we go to classes, let's talk about extension functions. So what are extension functions? Well, it's a little weird. In the case of Kotlin, you cannot inherit from classes unless the classes are open. So by default, classes are final. But you cannot inherit from it, but you can add methods to existing classes. Well, to be fair though, they don't actually do bytecode injection. Instead, they turn these into static methods that get called. So as a result, you're not really compromising any of the encapsulation boundaries of the object in any way. So let's say for a minute, I have a greet is equal to, and I'm going to say in this case, hello, and I'm going to say print the word value for greet, and you can see in this case, the greet gets printed. But what if I want to say shout? Well, obviously we can agree that if you're meeting a friend after a long time, you definitely don't want to whisper hello, you want to shout. Well, sadly, that method doesn't exist. I think it should really be part of the JDK. But what if you really want to add a shout method? Well, you can simply say over here a string, well, first of all, function, a string, and I'm going to call it shout, and simply implement the method like the way you want to. So uppercase, for example, and then when you run the code, you can see it is going to print that in uppercase. So you can start adding methods to classes as well. But of course, what it's going to do is to turn this into a static method, and the static method should be in the context of your import. So whatever package or level where you injected this particular method, it's got to be imported for you to use. If you don't import it, this won't be visible. So once you import it, it becomes available, and of course the compiler will rewrite it as a static method. How do you qualify which one? Yeah, so a couple of small details. If there is a member function of the class, then it always takes precedence. It will not really use any of the extension functions at that point. If you do have a conflict between the two, then it's going to win over depending on which one you're importing. And in the worst case, you may get an error. In the best case, it may win over one of the overriding extension functions, but never compromise a member function.
So you couldn't like combine.
No, you can't do that. Mm-hmm.
And anything that returns or infers a string, you can call shout on that within what you're doing.
Yeah, because you added to the string class itself in this case. So as a result, as long as that's visible to you, you can call a shout on any string. Yeah, absolutely. Yeah. Mm-hmm. You cannot you mean override it. You cannot override it because it's not part of the class. You can add parameters to it, yes. I'm not sure what, like you have an existing function, you're overwriting another one. Yeah, it's because it's basically a static method you're writing. It's not conflicting at that point. Yeah, but you cannot override it though. So if you're inheriting from a class, you cannot override it because it's not a member function. It's a static function. As we know, static functions are not polymorphic, so you cannot override it. But overloading is fine. But again, you should use a judgment whether it's a good idea. It can become confusing. Yeah. So in a sense, what's happening is if you have more parameters here, so for example, you want to say a level, and again, assume that in this case, you have a shout as a method in the class for a minute, then you can say level, but obviously the way this actually works is this actually becomes the first argument, and the level that you're going to pass to it becomes a second argument. That's the way it actually works, so that's not a problem. Yeah. So with that said, like I said, it's not part of the class itself. What about creating classes? Well, like I mentioned earlier, classes are final by default. Unless you put an open, they don't become available. But how do I write a class? Well, this is a minimalistic design here. So I'm going to go ahead and say OK. And you can see that the code doesn't have any problems with it. So you don't have to put a lot of ceremony into it. I'm a big fan of this approach because I believe in writing test and writing code. So when writing test, I don't have to fill in an object with unnecessary things when I don't have enough to do. So I can start small and start moving further. So what if I want to create an object of this particular class? I can say car equal to car, and I'm going to print the car right there. So you can see that you're using the Python notation to create the object. You don't use the keyword new. There is no keyword called new in Kotlin. pun intended, I said there's nothing new in Kotlin, right? So you cannot use the new keyword in Kotlin. Well, but you can create the object much like it's a function, so that actually makes it easier to create fluent syntax like DSLs that can become a lot easier. What if I want to pass to it a little parameter? So this is writing a constructor actually rather than a class. So you can say year integer, and then of course you can specify 2019 over here, and as a result you can print car.year and you can print it. Now just quickly to make a note, it is important to keep in mind that year is not a field. In Kotlin, you don't have access to fields, period. You can use what is called a backing field, but that's only within a property can you access a backing field. Anywhere else, you don't have access to the fields at all. These actually are properties. So if you were to compile this to bytecode and take a look at it, this call right here becomes a call to get year. So it is not a year field you're accessing, it's a property that you're actually accessing. Well, this is a read-only property. So if you say year equal to 2020, you get an error because you cannot mutate a val, you cannot reassign to it, so that doesn't allow you to do that. On the other hand, well, before we go further, as far as properties are concerned, they are a lot like C# properties. So in C#, you know how you can create properties, and of course you can have a backing field created in C#. This is very similar to that idea. So this is very much like C#, except they've gone a little bit further with a few other things. So for example, if I were to say var, and in this case I'm going to say color, and this is going to be a string. What I can then do is, when I create this object, I can say blue as a color for this particular car. So if I want to print it out, I can print the color value right here, as you can see, and that becomes a color. But color is mutable because you said var. So if you really wanted to, you could go back and notice that the color is blue when it prints out. But what you could do is you can say car.color is equal to, let's say, orange. And then of course, in this case, the color becomes an orange color. You could do that as well. But similar to this, when you write things like this, these become properties right off the bat. So right now you have a read-only property called year and a read-write property called color. But what if you don't want a property, you just want to pass some initialization data? Well, then don't put var in front of it. Simply call this as initial color, if you will, and that's no longer a property. You cannot access it. So if I were to run this code and say car.year, you are able to get the year of the car, not a problem. But what about the initial? Ignore the warning just for a minute. What about the initial color? You cannot say in here car.initial color because that's not a property. So that is just a parameter passed in for the constructor. So now what you can do though is you can say car.color, and you can print the color, wherein the color could be a var, color is equal to initial color. So right now the color becomes a mutable property in this particular case. Now what if I were to say print line car.color, but in this case I'm going to say car.color is equal to red. And as you would expect, the color can be mutated, and as a result it can change its value quite easily as well, and so the value is being mutated. Though it started with the value initially as blue, you're changing it to a red. But of course, what's the benefit of doing something like this? What if I send an empty string, for example, or something that shouldn't be given? Well, what you can do then is you can say get. Well, this is a little bit of surprise here. You don't put a curlies like we do, so it almost feels like writing Python for just a minute. Now, you don't have to put the indentation, but it's a convention. It's good to have indentation. So you can say get over here, and this is going to be a value, and you use the word field. So the field stands for the backing field I talked about. So similarly, you can say set, and that takes a value, call it whatever you want to call it, a string. And what do I do within this? I can say field is equal to value, and I can set that value right in there. And as you can see in this case, the value was blue to begin with, but I modified that to an empty string. But what if I don't want to permit that? Well, pretty easy. You can say if value is let's say equal to empty string, or you can use a trim, if you will, to make that much better. Then what do? You can say throw, and remember there's no new, so you say throw runtime exception, for example, and then you can say you passed an empty, how dare, you can threaten the programmer. So you can pretty much throw an exception disallowing that, and of course if the value were something else you can permit it, otherwise it blows up on your face and gives you an exception. Please.
So here the get and set methods are linked to that field by proximity? You get them after it?
It's actually not quite as a proximity. It is every property has a backing field, and as a result it refers to that property's backing field. And if you are in another property, you have to use the property to get the other property, which is actually pretty nice because you are engaging polymorphism to get it. So if the property were to be overridden in a derived class, you are still accessing it through polymorphism, so that works really nicely. So that's why you are not allowed to access that field from the outside. So they're kind of encapsulated pretty nicely. Of course, if you do generate the bytecode from Java, you can do whatever you want to do, whereas within here they kind of protect it. Yeah. So that is about properties and the backing fields of properties. We talked about it. You can make the setup private as well, and of course if you do, you cannot access this from the outside. So you can say that you can read my property, but I can only change it from within my class, not from my outside the class. You can do that as well. So you can have setters internally for that. Kotlin quite doesn't have static methods. So if you really want to come close to static, you have to create what are called companion objects. A companion object is an object, a singleton you create within a class. If you're familiar with Scala, the ideas are very similar to what's in Scala. So the companion object becomes part of your a singleton for your class, and then the methods are part of the companion. So you use the class name to access it, but it gives you an illusion of static. Just a quick side note, if you do want to access them from Java, you won't be able to because they're not static methods in Java. Well, in that case, you can use an annotation called JVM static. Then Kotlin will create them as a static method. So in other words, Kotlin thinks that you're writing code to use within Kotlin itself, which is true if you're writing Kotlin to write Android applications, for example. You're going to write predominantly code in Kotlin. You don't have to create Java-specific bytecode for use from Java. But if you do plan to intermix with Java, you got to throw some annotations so that Java will be able to integrate, Java code will be able to integrate with Kotlin code properly. Data classes are another beautiful things. Data classes are intended for creating classes that are more for representing holding values of data. But what is the benefit of creating a data class? Well, you get one and buy a few things free. You get the constructor, you get a copy function, you get also a deconstructor available for you, the equals method, the hash code method, and a pretty nice written two-string method. So class car, for example, year integer, let's say val car is equal to car, and I'm going to say 2019, and I'm going to just print out the car right in there. So as you would expect, the car prints that information that you see here, which is going to be the value. Well, what if I wanted to print out some more details? I can say data, and when I run the code this time, you can see from the output that it is going to be a data class. Oh, sorry, pardon me, I forgot one thing here. No wonder it said year is not being used. Well, there you go. It's a field, a property right now, but that's an ugly output. But instead of mark it as a data class, now you can see that I get actually a fairly nice output of the year. Well, the two-string method is at play here. Similarly, equals and hash code and copy function, and of course, you're also able to make deconstruction very easily for this. Destructuring works really well also. Quick note about inheritance. Inheritance, as you know, is the weakest link in object-oriented programming. Well, in Kotlin, you can use inheritance, but they want you to work a little hard to use inheritance. So you cannot take arbitrary classes and inherit from them. You got to mark them as open if you want to inherit from them. Similarly, methods have to be marked as open if you want to override them. And when you override them, you have to say override to say clearly that your intention is to override it. So they make it a little bit unpleasant to use inheritance so that we will move away from using that. Well, remember Liskov's substitution principle. You need to use inheritance only when you want substitutability. Don't use inheritance for reuse. Well, obvious question is, if they make inheritance so hard, what do we do? Well, remember reading wonderful object-oriented design books. What did they tell us? Use delegation instead of inheritance. What did we all do in Java? We got together, we said, what a great book, what a great idea, I totally understand. And then we close the book and we use inheritance, isn't it? Why? Because there's no syntax for delegation in Java directly. Well, Kotlin supports delegation as a first-class citizen. I'm going to merely scratch the surface over here, but you can use delegation pretty nicely. And by using delegation, you can simply say, my methods come from this other object, and the things you don't implement for an interface gets automatically routed to this particular implementation. So this becomes an extremely powerful way to delegate. I'll just show you one example, a use case of delegation here, just to entertain this thought. So if I have a compute function which takes an integer, and I'm going to return an integer from here, and I'm going to say called right now, so you can know that this function is called. And I'm going to return, let's say, a simple value n times, let's say, n times 2. Well, in that case, of course, if I were to then call this, so what am I going to do? Well, if I say, for example, if I'm going to call the compute function and pass a 7 to it is greater than, let's say, 10, and I'm going to then say, or actually, let's do it this way. Val temp is equal to compute, and I'm going to say 7. Then I say if math.random of, let's say, greater than 0.5, I want to output, let's say, the temp. Otherwise, I'm going to say else, let's output a few dashes. Well, here's the good news and bad news. The good news is we put a temporary variable. The bad news is that temp is going to be used whether you're going to use the value or not. So you can see called 14, great. But if I run the code one more time, it said called and 3 dashes. What a waste, isn't it? Because you're not using the value of temp and yet you executed the code. Why bother? Well, what you can do instead is you can come in here and say val temp, and you can say by lazy, and then you can mark this as a lazy evaluation. Now here's a way to think about it. You're taking that variable temp and you're delegating its value to a lazy evaluation. The lazy will not run until the value is needed, and when it is needed, it will not run more than once. So for example, if I were to print temp a second time, it is not going to naively compute it one more time. It is going to really reuse it. So notice it printed 3 dashes right there, but if I run it one more time, it is going to then, when it comes into this particular, okay, I'll try one more time. So, and of course, when I run this now, you can see it said called once, not twice, even though we printed it twice. So that's an example of lazy. Similarly, there are other implementations of lazy, but you can implement your own delegation as well and make use of beautiful reuse of objects without spending too much effort. With that said, I want to quickly show you one last example for creating some amazing Fluent code. And for this, I want to show you 2 different things in here. Let's say we have a class called pizza, and the class pizza contains, let's say, a function. And in this case, I'm going to say spread. I'm going to take a topping. We'll just take it as a string. And all I'm going to do is simply print out spread and then the topping, let's say, that I want to print out. Well, if I take this code, I can create an object of pizza. Let's say pizza is equal to pizza. Then I can say pizza.spread. Well, if I call the spread function, I can spread maybe some sauce on it. Then I can also say pizza.spread. And in this case, let's say, let's take some olives on it. So if I were to run this code, obviously it prints the spread and those 2, but wouldn't it be nice to just leave out all this noise in the code and simply say that I want to call this without a dot and without a parenthesis? Well, it doesn't work, but it gives you a clue as to how to make this work. Notice it says infix modifier. So if you mark it as infix, you can then get rid of that dot and parenthesis, and you can write the code like this. And one other thing that is so beautiful, and yet when I saw this, I was quite unhappy because I didn't understand the magic. And I don't like magic. I want code to be obvious to me. And when I looked at it, I was very unhappy because I'm like, how does this code work? And I had to kind of switch back to something else to understand this code. So this is, let's switch gears to JavaScript for a minute. In JavaScript, if you have a function called func, you can do the following. You can say func and you can call with the value 7, or you can call func and you can do a call and send a context object and a 7. The context object you pass in JavaScript becomes the this within the function. So in other words, in JavaScript, you have this wicked feature. You can take an arbitrary function and make it a member function of your class. Now, that concept exists in JavaScript. Now, let's think about what Kotlin does with this. Imagine taking an arbitrary lambda expression and suddenly making the lambda as if it's an extension function of your object. I mean, this blows my mind because suddenly you can run this in the context of your object. Let's give it a try. So I'm going to say over here greet, and the greet function takes a name which is a string. I'm going to pass the string right in here. So for this purpose, what I want to do is simply say val greet, and the val greet is going to say equal to, this is going to take a string as an input, and it's going to return a unit. I'm just going to print it out, let's say. Well, in that case, what is the function going to do? It simply says print, and I'm going to say hello, and then print the name given to me. What is the name though? The name comes in as a parameter to this particular function. So if I were to start with this, I can call greet and say Jane right here, and of course it's going to say hello Jane to print it. However, you can come down here and say a string dot right here. And if you say string dot, this means that your lambda is going to run as if the lambda is a member function of that class. And so how do you make this work? And I struggled with the syntax, honestly. And then one day it dawned on me, oh my gosh, I know how this works in JavaScript. And I kind of took a deep breath and said, I'm going to write the code in Kotlin like I do in JavaScript. Literally, this is what I did. I put the word hello right there to run the code. And this time I said $this. And I was honestly absolutely shocked that this code actually ran. But then what they do is, they don't do it this way. They take this and say .greet, and they do Jane. And that is absolutely wicked. So this is the equivalent of it. You're able to run the method as if it is a member function. So you're able to hijack lambdas and run them like they are member functions of your class. Well, you can exploit all of these ideas to do something like this. You can say operate, and then you can say, for example, something along the lines of this, runs fast, and then you can say this turns left, and then you can say this turns, let's say, right. And this, believe it or not, is a valid Kotlin syntax now. How so? Because you can make the operate as a infix function. Now, what about this context object? Well, that could become the context object you pass in using the dot notation we saw, or you can simply replace this as it turns left. Well, in that case, of course, that becomes the argument you pass to it. But what about the left? That could be a variable in a context object, which you can pass it as a receiver, so that type dot dot, and by mixing infix, by mixing it, by mixing lambdas, and by mixing receivers, you can write very fluent code like this, and you can be on your way to write a completely statically typed, verified DSLs as well. And so I'm a big fan of metaprogramming. I'm a big fan of writing DSLs, but one thing that blew my mind in Kotlin is not only can you write very flexible DSLs, but you can also get compile time verification as well. And that's a big bonus, because when you write the code, you're not just hoping the user typed it properly. You know that they typed it properly because you can verify that pretty nicely as well. So to summarize what we talked about the power of Kotlin right here. And then Kotlin, being this language, gives you this capability to write code into different targets, whether it's Java or JavaScript or Android or native or WebAssembly. Well, the development of these are in different levels of maturity, but it's really coming along pretty nicely in terms of the power. When you look at Kotlin, people often tell you it's a much fluent Java, But I do want to emphasize it's a lot more than that. There are so many things in Kotlin that simply are just not better Java. They are doing some things so remarkably different. I haven't even touched some of the major capabilities like coroutines that are in the language, which is pretty amazing. So you can exploit some of those capabilities really nicely. It's a language that is very mature. It's a language that's being used quite extensively. I see this being used quite a bit in a lot of different organizations. I've been working with a few companies and training them towards getting their team up to speed in Kotlin as well. Clearly, the Android world is much more inclined on this, but even on server-side Java, this is catching up as time goes on. So you're beginning to see this quite a bit as time goes on. Yeah, please.
Are there any licensing restrictions?
No. In fact, that's one of the plus points as well. The folks behind JetBrains have said this is free, and this will definitely continue to be free. So it's extremely flexible from that point of view. Part of the reason why Google embraced it as well. I mean, it's a great language, no doubt about it, but it also doesn't come with some baggages as well, which is pretty good. Yeah. Any other questions or comments? Please. Why wouldn't I use Kotlin? Well, maybe my team is not mature enough to adopt it yet. There could be concerns in the organization level to adopt it. That could be a reason. Or it could be that maybe I am really doing more front-end development, and I don't really care as much to personally to use it. Just because it can doesn't mean I should. And maybe over time, as things become more mature, I might really consider it. So it really depends on the needs of the project. So one of the things I always emphasize is I never go to organizations to convince them what language they should use. Most of them, what I do is I say, if you call me, I'll make you better at what you do. And if you ask me what's better, that'll be a different answer. But I'm not going to come and sell a language to organizations. So I believe in doing the right things for organizations because their needs are quite extensive and different. And I don't want to become that person to say, oh, you should use this and everything else is bad. I think there are several really good languages. Kotlin definitely is one among them. So I don't want to say this and nothing else. That would be unfair to a lot of languages as well. That's not the case. But it's definitely a very mature language worth considering. Yeah. Please.
Kind of a related question. Comparing Kotlin and Scala from the perspective.
This topic is over. Can we go home now? I try not to do that in general. Mainly. Usually I don't answer these questions, especially when I'm being recorded. Because there are other consequences to me answering such questions. So I'll be more than happy to talk privately, but I'm not going to answer that right now. Yeah. Yeah. Please. You bet. So this predominantly is for a data class. So if I were to say a data class, let's say person, and then I'm going to say, oh, let's say name is going to be a string that's going to come in. And in this case, of course, it's going to be a val. And then I'm going to say age, which is going to be, let's say, an integer. And then if I were to create a person is equal to person, and let's say this is going to be Sam and 2, well, I print the person. Clearly, data classes do a few things for us. So in this case, you got this. But what if I really wanted to say get the name value out? So you're receiving an object right now on your hand, ignoring the code on the top. You can say name is equal to person.name, and then you can say val age is equal to person.age, and then you can print out, let's say, name of the person and the age of the person, and you could print it that way. But on the other hand, though, imagine pulling 5 or 6 different properties like this. It becomes tiring. It becomes really verbose. So what you can then do is you can simply say over here a name comma age, and you can pretty much pull in the values in one shot. So when you do this, you can pretty much say, why don't you just grab me those values and give it to me in one shot? Now, what becomes even more exciting here is, imagine for a minute that kids these days, let's say this kid has the email already, and you have a val which is a string, and of course when you're creating this, you're going to say this is going to become sam@example.com. Well, if we run this code, you have pulled the name and the age properties, obviously. However, let me remove the print over here so it doesn't get confusing. So you brought the age and value. But what if you want the email? Well, you can come back and add the email right now. And as a result, of course, as you know, you are able to pull the email. But obviously the question is, I don't care about the age. What if I don't want the age? Well, then don't bother with the age. But as a result, you can simply say underscore. I love this underscore because underscore is the international symbol for I don't care. So you can pretty much say I don't care to pull it in, and so you can use a destructuring syntax like that. If you're writing your own classes, well, what they're doing under the hood is it's positional. So based on this is component 1, this is component 2, this is component 3. So literally behind the scenes, they're converting this into mapping the call to component 0, call to component 1, and call to component n to the appropriate variables. So they do the unwrapping for you, so you can write a concise syntax and walk away. Please. Oh, let me quickly answer. Yeah.
How would you just briefly describe Kotlin to someone who's using Scala?
Say that again for me.
How would you briefly describe Kotlin to someone who's already using Scala?
Yeah, like the way I described to him, not on camera. Yeah, please.
I used to work with Google Web Toolkit, which was pretty popular for letting you use the benefits of strong typing, but running in browser. Right? Is Kotlin being used that way as well?
So clearly you are getting the benefit of static typing, but I would say I wouldn't say extensively being used compared to where it's being used in Android. I don't think it's as extensive. So it'd be unfair to say it's being used extensively. But there are people who are using it. You're getting the static typing, but I wouldn't put it to a stretch of imagination saying it's extensive at this point. That could change in the future, but that's not quite right now.
Can you do keyword destructuring on data classes?
So by using the names itself, not to my knowledge, no. Yep. What are some of the drawbacks to Kotlin? Well, some of it's a learning curve, right? And let's be honest about it. People will tell you it's easy to learn. It's relative. The language has enough of capabilities in it. So if you're going to start using Kotlin, you will get into it very quickly and say, yeah, this is great. I'm going to start using. Look, this is much cooler than Java. But then you start realizing there are enough differences. And then you start realizing that there are enough features that we don't even expect to see in a language like Java. Don't get me wrong, I love these features. But I'm a language geek. I spend my time on this, a lot of time on this. But if you consider a team which is doing predominantly Java, there is a learning curve, and you have to go through that learning curve and be ready for it, right? It's not like you're going to just roll over and start coding in Kotlin tomorrow. Everything is going to be too easy. You have to take the time to learn. That's one disadvantage you have to go through. And to me, that's probably the only thing I can think of, right? There's nothing else that limits you from using that. Just be realistic about it. And as long as you're realistic about it, you're not overselling it. And that's one of the things we should be careful about, because if somebody oversells it, and then when people find that there are issues to cope with, then it becomes disappointing. But if you set up a stage properly and say, it is great, but here are nuances, and you need to take the time to learn this. And a lot of times what happens when languages become mature is that's exactly what happens. People kind of get infatuated with it, and they jump on it, and they say this is the best thing since sliced bread. And then once that initial honeymoon is over, then they begin to realize that there is steps to climb, and they are not happy with it at that point. Kotlin has less of it, but still, it is there. So you need to be ready for that. Please.
How come there are generic users?
Oh my goodness. We can speak for another 2 days. I love what they have done. So in terms of generics, first of all, 2 things. One is you have reification built into the language. So reification works only with inline functions. So you don't have to pass a class object to functions as we do in Java. You can just say reified, and then you can do checking for the type, and you can do casting for the type as well. Well, clearly you cannot do this in Java because of type erasure. Even in Kotlin, you cannot do that without reification. But the minute you say reify, the compiler will then know the type at compile time and expand the code because it's inlined. Secondly, Kotlin has a beautiful feature for both covariant and contravariant. I do have to say, this goes back to his question, this is where the learning curve is. In the book, I caution people several times. I say, stop reading now, take a walk, take a breather, get some coffee, and then when you're clear-minded, come back and sit down to read this section because it's going to hurt your head. It is complex. And with covariant, and then you can do declarative variance, and you can do use site variance. It is quite complex, but very powerful. But by doing that, you are able to create data structures which know how to handle compatibility. For example, I have a collection of base. Can I send a collection of derived or not? Well, Liskov substitution principle says you shouldn't. Well, here you can actually clearly define when it can happen, when it can't happen, when it cannot happen. And so they've given a really powerful set of capabilities, but I would say you have to take the time to learn that. It's not easy. I would not classify that as walk in the park. It's going to take several iterations to get comfortable with it. Yeah.
Does Kotlin support Java annotations for interop?
So the answer is yes. So there are a slew of annotations. Does Kotlin support Java annotations for interop? So let's step back and answer the question a little bit. If you're going to go from Kotlin to Java, it is almost no problem. And I say almost because there's always edge cases you will come across, and then you have to work around. So Kotlin to Java is almost easy. Java to Kotlin, on the other hand, is nothing but. And when I say nothing but, I want to classify that. I'm not saying it's impossible. I'm not saying it's hard. I'm saying it takes effort. And the reason it takes effort is, in the case of Kotlin, when you're writing overloaded functions, when you're writing functions with, default arguments, or you're writing functions with, let's say, companion objects, you have not planned them to be static, well, those methods don't appear as static. Or you have a function in which you throw an exception. Kotlin does not have, thankfully, the concept of checked exceptions. You can throw exceptions anytime you want to, and you don't have to say throws to say that. You can catch exception anytime you want to. You don't have to say, oh, they're not throwing it, I cannot catch it. There's no concept of checked exception. Good news, there's no checked exception. Bad news, if you compile that to bytecode, then you don't have a throws clause on it. If you call that function in Java, you cannot put a catch block around it in Java. So now you have to come back to Kotlin and say, I want to add an annotation to say throws, so the bytecode will have the throws clause. So these are the things you have to kind of look at, and there's like JVM default, JVM static, throws. So you have to annotate. Well, so the answer is, are we going to waste our time annotating the heck out of this? So the answer to that is, think of a circle. Within the circle, you have Kotlin code which you plan to use within Kotlin. These are your internal API. Don't waste your time annotating. Come to the boundaries, and only in the boundary, if you know that those will be called from Java, then annotate your boundaries. So it's a nice compromise. While you have to annotate, you don't have to annotate everything. So you can clearly define what is your internal API intended to use within Kotlin, what's your external API you intend to use from Java, for example, or other JVM languages, and then start annotating only those things. So you can do that. Yeah, so you can definitely do that fairly easily. So interfaces are written in a very similar way. You don't use the word default to write default methods. So you're basically writing interface. But if you're going to implement an interface, all you do is you say class, my class, and then you put a colon and say interface to implement the interface, whatever, my interface, right? So you're basically using the same syntax for inheritance, extends versus implements. There's no separate keyword for it. It's pretty straightforward, so you can implement it straightforward like that. And of course, when you implement multiple interfaces, you're going to face the consequences of that. If there are method collisions, you have to resolve them and such things. So it's pretty straightforward.
We're running out of time. We still have to tear down the room and head over to the house to do door prizes. Can we limit it one more last question if anybody has one?
And you just asked, so can we? And the answer is yes. So that was the last question then.
Okay.
Thank you.